Now we will start our technical session. So for today, our first presenter is Mr. Jimmy Mazumdar. He is a student at Kyushu Institute of Technology, and his topic is the study of development of smart assistive robotics walker for walking rehabilitation system and health monitoring of PD patients. So, Jimmy, over to you.
Okay, thank you very much. Thank you, everyone. Thank you to the program chair and the organizer of today's conference. Uh, I will discuss about our recent study and development of an intelligent smart walking robotics walker for walking rehabilitation and health monitoring systems of Parkinson patients. And this work, we are doing this project at Kyushu Institute of Technology, the Graduate School of Life Science and System Engineering under Professor Shibata's supervision and in the Shibata laboratory. So today I will discuss like in total slides in 7 chapters. So including all these chapters, I will try to describe the research and studies and what we are doing and what's the key achievement we did by this project. So first of all, I would like to describe and as we know that world population and aging and mobility is rapidly increasing, and like everywhere all over the world population is increasing, and aging is very like it's common issues all over the world. So even it is predicted that 16% of the world populations by aging is over 65, it will be rapidly increased. So it's like kind of challenging for us. And another thing is like mobility limitation is one of the common phenomena for aging people. And in aspects of mobility and walking issue, there are some common issues like motor implementation and skeletal deformation and heart rate fallings. So why we focus this research in Japan? Because Japan is also rapidly population is increasing, and we can see like from this flow chart that it's rapidly increasing the world population considering within Japan also. And in Japan, the highest populations of the aging is like predicted 38%, it will be like 65% by 2015. So it's very challenging and very complicated situation in Japan, that people who are elders, they're really suffering a lot, and it's really they're frustrating and facing serious mobility issue. So from this effort, like, and also like in Japan, shortage of caregiver, it's very common, and 1.8 billion caregivers in 2021. So it's expected that in 2025 it will be like 2.553 millions. So from this all over the effort, we are also thinking about what's the major problem with the aging. So Parkinson disease is very common, like for motor and non-motor symptoms. I think already we discussed about these things, like already in the previous speakers they mentioned about the talked assistive robotics, and many speakers they already mentioned these things. So we mainly focused on Parkinson diseases to improve their walking rehabilitation, and also we are focusing like the fog analysis, because it's half of the Parkinson diseases they're facing fog analysis, like falling case and physical unstable. So the problem with physical unstable and fog means like freezing of gates. So as we know that when fog appears at the time, the heart rate also changing, it's before or after. So uh, we should consider the physical phenomena like health conditions and uh, others behavior analysis of the Parkinson diseases, so that we can provide a better rehabilitation monitoring system. And as you know, like more than 1 billion people needs assistive product, and also robotics worker is a fundamental demand. So some of related researcher they also work on robotics worker. So but the thing is like most of the worker system they focused on freezing of gate analysis, I mean fog analysis, and some of their assistive quality is very low, some of them quality is medium, and some of them quality is high, especially like in Kyushu Institute of Technology, in our laboratory we developed a smart robotics walker, so our assistive quality is high. And what we did, we analyzed fog, and we try to analyze many physical phenomena with the walking rehabilitation system for Parkinson disease. And in this research, uh, especially we focused on system development, system integration, and system update and implementation. So what we did with system integration, we developed an intelligent smart robotics walker as a assistive mobility training device that can provide better rehabilitation system. And in addition, we also designed a control framework, like a complete framework with the heart rate monitoring system and rehabilitation system. And in addition, we try to complete the framework, and we try to investigate with Parkinson disease and healthy patients. Then we try to make analysis, and after that our aim is to integrate this complete system in an existing walker. And from this development effort, at first we focused on controller side, like velocity, torque, and impedance control. And after that, we try to make a framework like position based control feedback, and walking force based velocity control, and rules based voice assistant system. So I can show, like in the figure 1, at first we make a position based feedback, and in the figure 2 we made another walker that for like speed based feedback. And finally we try to make a complete framework, and in this complete framework we used voice assistancy, velocity control feedback, a heart rate monitoring system, and also some work is progressing like walking intention based feedback. So for this framework we develop a voice assistant function, so like for a start walker operation, for the speed, to control the speed, because the PD patients, they need to control the speed for their different types of walking. And another is like distance, we need to fix a distance. So if they set the voice distance, voice command, from this voice command the distance is also fixed. And also there are some another features like to stop rehabilitation, because for Parkinson diseases continuous walking is very challenging, so stop mechanism is also very important. So we operated this stop mechanism with ASR monitoring system like heartbeat, and we used PPG sensors that I'm discussing in the later in the framework 3. So in third framework we can see we used PPG sensor, and we use heavy actuators and Raspberry Pi voice assistants and batteries and so many things, like a complete framework. So that's the main component what we used: heavy actuators, microphone array, speakers, and PPG sensors. I think you know about the PPG sensor, and also Raspberry Pi and the heavy actuators. So we try to make a complete prototype device so that it can provide the better rehabilitation and monitoring system. So this is the architecture I already described about what's the component we used, but later we try to update this system. So uh, our aim is to make a complete framework, so that we can monitoring health rate, and also we can monitor, we can provide better rehabilitation with the walking parameters, walking posture, instead of falling case. So uh, yeah, from this architecture you can understand like what actually we try to do. And we also provided a IoT based environment system, so that PD patient, they can know their physical phenomena, and also the therapist, they can also get the information for monthly or weekly for treatment or training to the PD patients, because it's very important. Very few devices are providing information, real-time information. So our aim is also to provide real-time health conditions and health monitoring systems. So in addition, we try to investigate our system performance. At first we investigated our system with a healthy object. It's like 26 years non-PD person. And another, in addition, we try to investigate the same system with over 60 years a PD patient. And in that experiment, we our desired distance was like 10 meters steady line, and the speed of the walker was like 0.4 meter per second, 40 meter per second. and we measure heart rate patterns, motor motions, and feedback while stopping. So in that, this is the results that we after investigation we recorded the result of ISRIAH patterns, because we can see from here that when the non-PD and PD patients, they are performing with the walker, at that time the feedback from the walker and the ISRIAH patterns is totally different. So we try to investigate the physical condition, that what's happening with the PD patients. So later uh, we applied a stop mechanism, like because I already mentioned that for PD patient continuous walking is very challenging. So with the 10 meters of parameter, uh, the PD patient was not able to complete the tasks. So before, during the 10 meters walking parameter, the stop time was 3 times. I mean, for PD patients, she had problem like the fog appears. So at that time, we can see in the red mark that when the walking performance of the feedback from the walker stopped, it's like, and the heartbeat also changed. So that was the uh, our prospective results from the experiment. And finally, this is like our overall conclusion. What we aims to do, our aim is to provide like a better training system, and we also provide like voice-based virtual assistants. So why we provide the virtual assistants? Because it provide better assistive support, and it's a wide range of uses. Like people all over the world, they use different types of voice assistants, like Siri, Google voice assistant, so many things. So we may develop the same kind of assistive voice assistant support, and in addition we also provided a IoT based serial monitoring system, so that the user, they can know their physical condition, and also uh, the therapist, they can easily observe the freezing of gait conditions and also health rate conditions. And in addition, our aim is to analyze different types of health related conditions. So yeah, that's it. Like in the future we will try to adapt this uh, smart robotics walker, intelligent smart robotics walker, with UPSPD, because UPSPD, that's another research of our laboratory. So UPSPD is artificial muscle. So when fog appears, heart rate changing, and fog appears, we can investigate these two things. Then we will try to make another framework with the UPSPD that will provide better working support. So, and in total, our goal is to make a complete walking based rehabilitation monitoring system at Shivada Laboratory at Kyushu Institute of Technology. And by this research, we already achieved some, like we published 2 papers, and in SI conference, and another like is processing, Robomec upcoming. So it was like a smart robotics walker system and health monitoring and walking rehabilitation system. So that's all for today. Thank you very much. If you have any question, please feel free to ask me. Thank you.
Thank you, Jimmy, for such a nice presentation. So, yeah, from audience, if you have any questions, kindly you can ask. Okay. Jimmy, I have a question. In your experiment, the experiment is conducted how many times?
How many times means, actually we had a desired distance like 10 meter of steady line.
Yes.
Yeah.
So
And
the graph you which you have shown, it's
yeah.
a result of one one experiment, or it's a average of many experiments?
No, it's like 2 experience. One is PD patients, and another is this is, you can see, non-PD patient, and another is PD patient. And later we compared with the PD patient's heart rate, and with the PD patients, while how many times she stopped. So she stopped 2 times during 10 times of 10 meters of parameters.
Okay.
Because in that point, like 88 and 71, in that point we predicted that that time is the fog analysis, I mean freezing of gate. So that's our another research. We will try to figure out like when fog appears. And as I mentioned in earlier, like from this case study, uh, yeah, you can see from this case study we found that heart rate changing before or while fog appears with the Parkinson disease, but they did not mention the accurate result. So in that case we are trying to find that what's the real time fog and heart rate changing. That's our desired expectation. I hope you got it right.
Yeah, I got it. Okay, thank you for your answer.
Yeah, thank you very much.
From audience, do you have any questions? Okay. I will. Okay. Once again, I thank you, Jimmy, for your nice presentation.